So examples of quotient rule. What's the big idea of quotient rule? The big idea of quotient rule is we're going to be using quotient rule anytime we have a function in the numerator and a function in the denominator. So can you give me an example of a function? So you can do a of x equals 1 over x. That's an example of a place where you could use quotient rule. 10 over x squared. Okay. So far, both of the examples you've given me are great because we could use quotient rule with these. These are sort of a common pattern, which is that you would be looking at a constant function over a power function. And the question is, can you give me one where it's not constant over power? Okay, x over x squared. And that's power over power. So can you give me one that maybe involves exponential or trig or so that's another one. So now it's really important to be able to recognize the types of functions that we're dealing with. And so when you look at these, it's like, this is sort of the key idea that people typically miss because we're thinking about these families as being different types, right? So if we wanted to do quotient rule, we could just say, all right, now I'm going to do these derivative calculations and I want to take the derivative of a of x equals 1 over x. So how would I do that? So I'm going to calculate a prime of x. So can you walk me through the quotient rule pattern real quick? So if you have f over g and you take the derivative, then that derivative is going to be f prime g minus fg prime all over g squared. So if we can identify the f and the g and the f prime and the g prime and we know the pattern, then all we have to do is plug in the pieces. And so however it works for you to memorize the pattern, my personal suggestion is just write the pattern over and over again every time you do the problem. So I'm going to write out a prime of x is f prime g minus fg prime all over g squared. And as long as I can identify f, g, f prime, and g prime, then I'm going to be good to go. So my f is whatever my top is here, it's 1. My g is x, so what's f prime? 0, excellent. What's g prime? 1. So excellent. So now I can plug in the pieces, right? So I can replace f prime with 1. I'm sorry, I can replace f prime with 0 because f prime is 0. So I have 0 times x minus 1 times 1 divided by g squared, so x quantity squared. You see how we got there? Then I'm going to take a prime of x. Now I can clean this up a little bit, right? Because 0 times x is equal to 0, so why write it? Minus 1 times 1 is equal to negative 1, and x squared is equal to x squared. So if I do quotient rule and I take that, I get that answer. That's good, right? Now the question is, could I have done this a different way? Because when you do a derivative, it's good to think about, could I have done this a different way? So the other way you could have done this is you could have rewritten 1 over x algebraically is equal to 1 over x. Well, I can rewrite that using properties of exponents as a of x is equal to 1 times x raised to the negative 1 power. Now, if I look at it this way, can I take the derivative without quotient rule? I'm not going to have 0 here because this constant is being multiplied by something. So it's just going to hang out. So you did the derivative perfectly there using power rule. And then from there, we are going to take that power rule and we are going to rewrite this as a prime of x is equal to negative 1 times x to the negative 2, which then becomes, now I want to rewrite this so it looks, I don't like writing things with negative exponents if I can avoid it. Yeah, negative 1 over x squared. Now notice, that's the same thing that we got in both places. So we wound up with exactly the same answer using these two different approaches. So which approach did you think personally was easier once you did both of them? Yeah, if you recognize this algebraic rewrite, this goes quicker. But this one doesn't require you to think very much about how, oh, this is actually equivalent to x to the negative 1. So it's totally up to you which one you prefer. 10 over x squared is the same situation. So if I have b of x is equal to 10 over x squared, I could do that with quotient rule, or I could do that by rewriting it algebraically and using power rule. So option 1 is to do quotient rule. The other option is to rewrite algebraically and do power rule. And both of them will get you to the equivalent answers. So it's up to you which one you like. Which one do you want to do first? Cool. So you've already got the pattern. I see you writing down the f and the f prime and the g and the g prime. F is 10. So f prime is 0 because 10 is a constant. G is x squared. So g prime is 2x. Awesome. So I plug that into my quotient rule pattern, which would say b prime of x is equal to f prime of g minus fg prime all over g squared, which is then, okay, plugging in everything, f prime is 0 times x squared minus 10 times 2x all over x squared quantity squared. You have to square the denominator. So this is really, really silly, but I imagine a person walking through a place called Denominator Square, like Times Square in New York City, and they have to go down into it. So they go down and they walk through Denominator Square. So I remember the denominator is squared. Okay, so x squared squared, I would want to clean up a little bit. So I would actually want to clean this up. 0 times anything is 0 minus 20x all over x to the fourth, and then b prime of x is equal to 0 minus 20x is just negative 20x over x to the fourth, and then finally b prime of x is equal to negative 20 over x. That's a really good question. So I have an x to the 1 on top and I have an x to the fourth on bottom. So the way that I think about this is negative 20 times x over x times x times x times x. I'm canceling and I'm just left with 3 x's on the bottom and no x's on top. Yeah, so really glad you asked where the x cubed came from. Now, once you get used to it, you don't have to write this out anymore. You just recognize that cancels, but it's helpful to do that to actually think about it. You notice we did a quotient rule here, which meant we could just jump right into it, but we still had to do algebra because we didn't want to leave it like this. So the algebra came from simplifying after we applied the rule. Now let's go ahead and just do it. What would it look like if we rewrote it algebraically and did power rule? So if I rewrote b of x equals 10 over x squared, and I rewrote this algebraically, how would I rewrite it so that it didn't have a denominator? I can bring this x squared up and I can rewrite it as b of x is equal to 10 times x to the negative 2. Now, lots of times people think, oh, I took the derivative. This is not b prime. This is just b of x, a different way of writing. So then my thing is, okay, I have my b of x. Now can I do b prime of x here? Well, what happens to this 10 when I take the derivative of 10 times x to the negative 2? It just stays there. So it stays as 10. And the derivative of x to the negative 2 is times negative 2 times x to the negative 3, which means that b prime of x is equal to negative 20 x to the negative 3. You buy that? And then I get this b prime of x. So I'd like to bring this back down. So this x to the negative 3 means whenever I see a negative exponent, that means it might be happy living in the basement. The negative 20 over x cubed. And notice again, we got the same thing either way that we did it. The question is, do you want to do the algebra as the first step to make taking the derivative easier? Or do you want to do the algebra first so that when you take the derivative, it's already pretty much simplified? Or do you want to take the derivative first and then you have to fight through more algebra to simplify? And either way, you're going to have to do algebra and take the derivative. And either way, you'll get an equivalent answer. It's just a matter of which one you like better.